This is unit number 5, video number 15, percent yield. So we're going to look now at percent yield. We understand stoichiometry, and we're going to look at determining percent yield. Because one of the things we're going to find out is what we predict is not necessarily what we're going to get, and it's not because of human error. There are lots of chemical reasons, and a big part of chemistry is determining where we end up towards what we theoretically should get. We call the amount of product that should be produced the theoretical yield. That's the maximum amount of product that a reaction could produce. The amount that is actually produced in the laboratory is called the actual yield. If a reaction is done the same way every time at the same temperature, we will always get the same actual yield. The same amount of reactants are used. It won't change, it won't vary, it will always be the same. So that's one of the things we want to understand. We can eliminate human error from our laboratory procedures. All right, we have the reaction here of gallium chloride with potassium hydroxide, making solid gallium hydroxide and potassium chloride. We want to calculate the percent yield. Now you might say, what is the percent yield? Well, let's go over here and just write out the percent yield is going to be equal to the actual yield divided by the theoretical yield times 100. This is what we calculate. This is what we do in the lab. So the amount we get in the lab divided by what we calculate to be the amount we supposedly should get. And as we said, it's a theoretical yield. Times 100, obviously, for percent, that'll give us the percent yield. As I said, the percent yield of a reaction at the same temperature is the same every single time. Okay? Once we get it down how to do it in a factory or something, it is exactly the same every single time. Okay, what is the percent yield of 25 grams of gallium chloride react with excess KOH if the actual yield is 15.65 grams? Well, we know how to do grams of A to moles of A to grams of B to moles of B. So our given here is 25 grams of gallium chloride. We're going to calculate the percent yield. Now, obviously, to do the percent yield, we need the theoretical yield. So there's really two things going on here. We're going to set the actual yield aside, calculate the theoretical yield the way we do with the normal stoichiometry, then come back and do the percent yield. Okay? So the 25 grams of gallium chloride, that's the most important. And then obviously we're also going to use the actual yield of 15.65 grams. So this is going to determine our theoretical yield. Let's do that calculation. We've got 25 grams of gallium chloride. So our A is gallium chloride. It's what we have, known quantity. Our B is going to be gallium hydroxide, what we're trying to find. And we don't have a statement here in gallium hydroxide, but that's what we're trying to find, gallium hydroxide. So, we're going to go through 1 mole is going to be 176.07 grams. That's going to convert our gallium chloride into moles. Now we're trying to find the theoretical yield of gallium hydroxide. Theoretical yield always has to be a product. We don't do theoretical yields of reactants. Okay, it's a yield, it's what's being produced. So we're going to have 1 gallium hydroxide for every 1 gallium chloride. Even though it's 1-to-1, write that out, because a lot of times it isn't 1-to-1. And then the molar mass of gallium hydroxide is going to be in the final step. Grams per mole, 1 mole, the gallium hydroxide is 120.75. 25.0 times 1 over 176.07 times 1 over 1 times 120.75 over 1 is going to give us 17.1 grams of gallium hydroxide. Trying to calculate the percent yield. Our actual yield is 15.65 grams of gallium hydroxide, so our percent yield is going to be equal to the actual 15.65 over the theoretical 17.1. 19.1 times 100. Plug that into the calculator and you're going to get 91.5% yield. That's our percent yield.